Hello students, welcome back to the class. Students, today in this class we will be learning about the carbon dioxide, which is a compound of a carbon. So students, first of all, this carbon dioxide gas was discovered by Van Helmont in the year of 1630. And how did he discover? By burning charcoal in the air. And then another scientist called Anthony Lavoisier, he studied the property of this particular gas and he named it as acid carbonic, because he found that the oxide of carbon and when they are dissolved in the water, then they form a acidic solution. And the molecular formula of carbon dioxide is CO2, which you all know and you have been learning this since class 6th. Its molecular weight is 44, and it occurs in the air in free form. It occurs in the air and it constitutes about 0.03% of the air. And apart from that, it is found in the earth's crust in the combined form. And some of them are limestone, which is calcium carbonate, dolomite, then magnetite, etc. Preparation of carbon dioxide. Students, how can we prepare carbon dioxide? First, by burning of carbon or the compounds which has the carbon in them in the presence of air. So when we will burn the compounds which have carbon in them, then what will happen? They will react with the oxygen present in the air, and then they will form the carbon dioxide. Like, suppose if we have here methane, when methane will burn in the air which has oxygen, then this carbon atom will combine with oxygen atom, and then carbon dioxide will be formed. Then next we have is by heating metallic carbonates and bicarbonates. So when metallic carbonates and bicarbonates are heated, then what happens? The oxide is formed. Like here, copper carbonate is there. When we will heat this copper carbonate, it will dissociate into copper oxide and carbon dioxide. Likewise, zinc carbonate, it will dissociate into zinc oxide and carbon dioxide. Then we have bicarbonates, calcium bicarbonate, sodium bicarbonate. So they will get dissociated into sodium carbonate and calcium carbonate along with the water and carbon dioxide gas. Third we have is by the action of dilute acid on the metallic carbonates and the bicarbonates. So students, when dilute acids are added to the carbonates and the bicarbonates of certain metals, then carbon dioxide gas is liberated. As you can see in the first one, here we have calcium carbonate, okay, and when the calcium carbonate is exposed to dilute hydrochloric acid, then calcium chloride will be formed along with water and carbon dioxide. Likewise, when sodium carbonate is exposed to dilute sulfuric acid, then sodium sulfate will form along with water and carbon dioxide. Then sodium bicarbonate, again with the dilute hydrochloric acid, it will form sodium chloride. This sodium from the sodium bicarbonate and this chloride ions from the hydrochloric acid, they will combine together and they will form sodium chloride along with water and carbon dioxide. Laboratory preparation of carbon dioxide. Students, how can we prepare carbon dioxide in the laboratory? So students, for this what we have to do is we have to take a round bottom flask, and what we have to do is we have to keep marble chips in it. Marble chips are, students, the little pieces of marble. The marble which you know, that particular marble, the little pieces of marble are called the marble chips. So what we have to do is we have to put a stopper there, okay, and there must be two holes in this stopper. Through one hole, what we are doing, we are connecting the thistle funnel, and through the other hole we are connecting the delivery tube. Now through this thistle funnel we are dropping the dilute HCl drop by drop, and it must cover these marble chips completely, and then you will see a brisk effervescence is seen, which shows us the evolution of gas, because calcium chloride, this calcium carbonate, like you can see in this equation, calcium carbonate plus dilute HCl, which we are exposing the calcium carbonate to drop by drop, it will give calcium chloride and water along with the carbon dioxide gas. So this delivery tube will it will transfer the carbon dioxide gas to the other apparatus that we have here, and it will be collected by the upward displacement of air. That means the air will go take the upper side, and the carbon dioxide will get accumulated here in the lower side because it is heavier than the air. Now students, what are the properties of carbon dioxide gas? Students, it is a colorless and odorless gas at the room temperature, and it is fairly soluble in the water, and as I have told you, it is heavier than air. It is 1.5 times heavier than air, and it can be liquefied by the compression. So if liquid carbon dioxide is allowed to evaporate rapidly, then a part of it forms solid carbon dioxide gas, which is called dry ice, and which is also used as a refrigerant. Chemical properties of carbon dioxide. Combustibility, students. Carbon dioxide gas is neither a supporter. It is neither a supporter of combustion nor combustible. That means neither it will burn nor it will help in burning. An action with the litmus paper. Students, carbon dioxide gas, it turns blue litmus red. That means it is acidic in nature because it is turning blue litmus red. In the photosynthesis also, students, it reacts with water and it forms glucose. It forms glucose and oxygen and water. Action with water. So students, carbon dioxide gas, on mixing with water, it gives a acidic solution which is carbonic acid. Action with lime water, students. This calcium hydroxide, which is lime water, when it reacts with the carbon dioxide, then it forms calcium carbonate plus water. And when this calcium carbonate is when excess carbon dioxide gas is passed through this calcium carbonate, then it turns it will this milkiness will go, it will disappear because of the formation of calcium bicarbonate. And when you will when on boiling this clear solution, the milkiness will reappear due to the decomposition of calcium bicarbonate. It will dissociate into calcium carbonate, water and carbon dioxide, and then you can see there is again the formation of calcium carbonate now. So again the lime water will turn milky because calcium carbonate has been formed. Action with metals. So students, metals like sodium, potassium and magnesium, they burn in the presence of carbon dioxide to form their metallic oxides, and then free carbon is also formed. Students, like as you can see, magnesium is here, carbon dioxide is here. So when they react together, when they are heated, so this oxygen atom will combine with the magnesium. Metallic oxide will be formed and free carbon. Then action with the non-metals. Carbon dioxide react with the red hot coke to produce a highly poisonous gas, which is carbon monoxide, which you have read in the second part of this chapter. Hydrogen reacts with carbon dioxide to form methane, carbon monoxide and water. As you can see here, carbon dioxide gas is reacting with hydrogen to form methane, carbon monoxide and water. And what happens when this carbon dioxide it reacts with the basic oxides? So students, we know that carbon dioxide is acidic in nature. So what will happen when it will react with the basic oxides? So first of all, sodium oxide, it will react with carbon dioxide to give you sodium carbonate. Okay, and then magnesium oxide, it will react with carbon dioxide to give you magnesium carbonate, sodium carbonate and magnesium carbonate. Now students, next we have is the tests for the carbon dioxide gas. Students, we all know that it is colorless, odorless and tasteless gas, and since it is acidic in nature, then it will turn blue litmus red, and it is not a supporter of combustion. So when we will bring a glowing splinter or burning splinter, then what will happen? It will get extinguished, and it also turns lime water milky, which is also many times used as a confirmatory test for the carbon dioxide gas. Next we have is the uses of carbon dioxide gas. So students, carbon dioxide gas is used in the manufacturing of many chemicals like baking soda, baking powder, washing soda, etc. Students, we have been learning that green plants through the process of photosynthesis, they utilize carbon dioxide gas from the air and they prepare their food with through this process of photosynthesis. It is also used in the manufacturing of aerated drinks, and it dissolves in the water to form soda water, etc. And dry ice, which is it also acts as a refrigerant to store certain items, and it is not a support of combustion, hence in the fire extinguisher it is mainly used. And when it is heated with ammonia under very high pressure, then urea is formed. And in the manufacturing of the carbogen, which is a mixture of oxygen and carbon dioxide gas, it is also used, and it is used in the hospitals for the carbon monoxide poisoning. Students, next we have is a soda acid fire extinguisher. So students, what you will see is here that there are two different glass apparatuses are there. In one there is concentrated sulfuric acid, and in the other one there is sodium bicarbonate solution. So students, they are this small one which contains concentrated sulfuric acid is placed in this big one which has sodium bicarbonate solution, and there is a plunger attached. So whenever a fire has to be extinguished, this plunger is hit with the ground very hardly, so it will break this glass bottle. And then what will happen, this there will be contact between sodium bicarbonate and concentrated sulfuric acid, and then this whole reaction will take place, and sodium sulfate will be formed along with the water and carbon dioxide gas, and therefore this carbon dioxide will gas come out through this nozzle, and it will help in extinguishing the fire. Next student we have is the greenhouse effect and global warming. Students, greenhouse effect and global warming can be studied through this. Students, we know how we are polluting our atmosphere through the burning of fuels in the automobiles or in the households and from the industries. So all these gases are actually getting released into the atmosphere, like carbon dioxide gas. As I have told you in the class also, that carbon dioxide gas has this ability to retain the heat. Therefore it is actually increasing the temperature of the earth, and when the temperature of the earth is increasing, this particular effect is called greenhouse effect. And this whole temperature increase is that is the global warming. And we know what are the harmful effects of global warming. With more heat trapped in the earth, the planet will become warmer, which means the climate all over the earth will change with the major changes in the wind and rain patterns. As you can see these days also, in December we didn't feel so cold, but now in the January we are feeling, because it is all the climate change, because and it is taking place because of the global warming. The rainfalls are also not anymore seasonal, because earlier the rains used to start in the end of June, but now it is like July, and then hardly we see a rain. It is because of this global warming, and that is how we are damaging our atmosphere, our earth, our environment.